Hello, today we're going to look at Group 17, the trends and variations in atomic and physical properties, specifically the trend in volatility of Group 17 elements in terms of the ID attractions. And we'll also be looking at the E0 values in order to determine how Group 17 behaves as oxidizing agents. We'll also be looking at Group 17 thermal stability in terms of the bond energies between the covalent bonds. So also a very short chapter. A lot of these ideas are very similar to what you have learned before. So I'm going to go straight into the quick recap of what you should know from chemical bonding. So the trend in bond energy of XX. So we know these ideas from chemical bonding. Specifically, what you need to know from chemical bonding would be whether you are working with the covalent bond or the intermolecular forces. So because I'm looking at the covalent bond strength, the XX bond, then we will be looking at the size of the atomic orbital. We notice that the size of the atomic orbital will increase down the group. So there's no need for you to talk about the nuclear charge, the shielding effect, the attraction of the valence electron for the nucleus from by the nucleus. You just want to go into the idea that the size of the orbital will increase. As the size of the orbital increases, the orbital becomes more diffuse, and therefore the overlap between the atomic orbitals will become less effective. If it is less effective, the energy required to break the XX covalent bond will decrease. So I will look at something small and cute, like say the chlorine, versus something a lot larger. And it's noticed that there's a much smaller overlap between the iodine atoms. The FF bond, however, is not as strong as expected because the fluorine is a very small atom. So even though I have the overlap happening, the repulsion between the lone pairs here will weaken this FF bond. So if you look at the data booklet, you'll find that fluorine is actually not as strong as we expect it to be. Chlorine will be the stronger bond in the group, and then it goes down to iodine. So in terms of the volatility of the halogen, so something that's volatile will have a boiling point similar, close to room temperature. So the halogens are nonpolar. They are both electronegative, but they will draw the electrons to themselves in a similar manner. So they're nonpolar, simple covalent molecules, which have ID interactions between the molecules. Down the group, the number of electrons increase. So we were looking at the MR as a gauge of how many electrons there are. So the more electrons you have, the bigger the molecule. This makes it more polarizable, and therefore the strength of the ID forces will actually increase down the group. So just notice that volatility will decrease, and the melting point and the boiling point will increase down the group. So this is similar to tutorial question 1. You may want to pause this video and go ahead and try tutorial question 1 to see if you can do it now. So exercise 1, they want to know what statements about the halogens from chlorine to iodine is true. So the volatility decreases down the group. So we know that volatility will change with boiling point. The boiling point is increasing down the group. Consequently, the volatility will be decreasing. The bond energy of the XX bond increases down the group. We know that the atomic radius is increasing down the group. The effective overlap between the orbitals is going to decrease, and so the bond energy will decrease. So statement 1 is true, statement 2 is not. The magnitude of electron affinity of X decreases down the group. So if we look at the EA. So perhaps we want to define EA first in terms of an equation. We're looking at how readily the atom picks up an electron. Because the atomic radius will increase from fluorine to iodine, the attraction of an incoming electron to the nucleus will change for fluorine to iodine. So because the iodine's nucleus is much further from the incoming electron, it will actually release less energy in this attraction compared to fluorine, where the nucleus of fluorine will attract the incoming electron more readily. So statement 3 will also be true.